Welcome back to the physics class, my dear students. Dear students, in the previous class, I just covered the refraction and also how the ray of light is going to bend when it travels from one medium to another medium. And also even we discussed regarding the refractive index concept. So as I said you that in the refractive index, it is just a measure of optical density. Just by writing the value of the refractive index, I just compared the two different mediums and also even the three different mediums, that is air, water and glass, and I just shown you which one becomes a rarer medium and which one becomes a denser medium. This is all we all evaluated. This is all how we studied all these things. Dear students, hope you all gone through the concept. Now just open your notebook, that is what points notes, and try to write it down. And I am just going to upload the PDF notes for related to this ray optics in the Google Classroom. Just check it out and move for writing of the notes. But in that PDF notes, I just highlighted some of the letters with yellow color box. So that thing you should not write. So please keep in your mind the things that what I just highlighted in yellow color, that you should not write in the notes, because those are all the concepts which has been deleted for this year. So but it is useful for your NEET and the competitive examinations. So just don't write those concepts which I have highlighted with yellow color, right? Now let us move at the next concept. So we should know some of the illustrations of refraction. That is what examples of refraction. When we come towards an examples of refraction, I can give you two best examples. That is what, if I just place an object under the water, otherwise if I just place a coin, and that above that I am just going to place a beaker which is filled with water. If I observe that the position of a coin, it is going to rise. Otherwise, you might have observed the glass slab in your 10th class. If you just place a glass slab over the letters so that the letters appears to be raised. This is one of the example which is an illustration for the refraction. Not only that, even we have so many examples, like if I just partially dip a stick or a pencil or a pen inside a beaker of water, so that the pencil or a stick or a pen appears to be bent. This is all due to the refraction of light. So that in the refraction of light, we can observe that we can move towards the discussion of normal incidence and all. My dear students, suppose if I consider for the normal incidence case, that is what I am just discussing the normal incidence now. Normal incidence. Let us see what happens in case of normal incidence. I am considering two different mediums, call it as medium 1 and medium 2. And even I am writing the normal represented by L. Let us incident a ray of light by the name PQ. So whereas this is the direction of incident ray with an angle of incidence I. I is the angle of incidence. Suppose if a medium 2 was absent, this ray should travel in this direction, right? But due to the presence of the second medium, the ray bent towards this direction, where QR is a refracted ray and R is the angle of refraction. This is what we observe. This is for oblique incidence, right? So the ray of light is incidenting in an oblique way, so slantly. But suppose I just want to observe the refraction. If I want to observe the refraction for different angles, so that I can make it like this, even I can bend the ray towards this direction, even I can make the angle very much lesser. Suppose if I incident a ray of light at this position, see, you can observe that. What is an angle of incidence? Normal is also here, ray is also here, so that the angle of incidence is 0 degree, right? So what is the refraction? It is not going to take any refraction. Why? Because it is for normal incidence. The angle of incidence and the angle of refraction both are equal to 0. Keep in your mind, for normal incidence there is no refraction. That is what Snell's law. Snell's law does not holds good. Does not holds good for normal incidence, because angle of incidence and angle of refraction both are equal to 0, my dear students. Now let us see some of the consequences of refraction. I am just moving towards the discussion of consequences of refraction. In that, first my part is to discuss what the lateral shift, my dear students. I am just moving with the discussion of lateral shift. See here, what is this lateral shift? So even we can discuss with the normal shift also, but first let us discuss with the lateral shift in case of glass slab, parallel sided rectangular glass slab. You might have studied the same on 10th class also. For my discussion, I am just going to write a rectangular glass slab. So this is my rectangular glass slab, whereas this is a glass, right? So let us name this glass slab as A, B, C, D. This is a rectangular glass slab. Whereas the refractive index of the glass slab is N. The refractive index of the glass slab is N. And the thickness of the glass slab is T. Okay, the thickness of the glass slab is T. Now dear students, on either side of the glass slab, we have air medium. Here we have air medium. Here we have air medium. But here it is made up of glass. So this is said to be the glass medium. I just want to observe the refraction in case of parallel sided glass slab. So these two sides are parallel, as well as other remaining two sides are also parallel to each other. Now let us write a normal to one of the parallel sides, right? I am just writing a normal one. Okay, this is a normal. Now let us name this one as N. Right. Now let us incident a ray of light by the name PQ on any one side of the parallel sided glass slab. The angle which was present between the normal and the incident ray is angle of incidence I. Now suppose if the glass medium was absent, the ray of light should travel in this direction, right? But due to the presence of glass medium, the ray of light is traveling from rarer to denser medium. Air is said to be the rarer medium, glass is said to be the denser medium, again it is said to be the rarer medium. Dear students, due to this reason, it is going to shift towards the normal, whereas QR is the refracted ray. So the angle which was present between the normal and the refracted ray QR is angle of refraction represented by R. Now you can observe carefully. Here the refracted ray is going to interact with the second surface of the rectangular glass slab. Whereas AD is the another parallel side, so that on that parallel side this ray is going to fall. Now at this point of incidence, I am going to draw another normal. So I am going to name this normal as N dash. Dear students, now the angle here is equal to R itself according to the mathematics. If the same angle is R, this angle should also be equal to R. Now in these two cases, the ray of light is travelling from denser medium to rarer medium. It should shift away from the normal. It should shift away from the normal. So that RS is the emergent ray. The angle present between this normal and the emergent ray is angle of emergence E. Even I can note it here, my dear students. I will note it and I will show you. Here PQ is the incident ray. PQ is the incident ray. QR is the refracted ray. and RS is the emergent ray. RS is the emergent ray, right? And I is the angle of incidence. I is the angle of incidence for the first surface, and this R is the angle of refraction. Angle of refraction, and E is the angle of emergence. E is the angle of emergence. Right. Otherwise, we can use other notations also. I can written as I1. This is R1. And here this can written as R2 and this can written as R2. I2, R2. See, hope you are getting. For the first surface, angle of incidence is I1 and angle of refraction is R1. And for the second surface, angle of incidence is I2 and the angle of refraction is R2. For entire glass slab, this is called as E. See, my dear students, I am using different notations. You can use I, R, E simply. Otherwise, you can use I1, R1, I2, R2. Right. So let us write for the first pair. So for the first pair, that is from air to glass. If a ray of light is traveling from air to glass, so that is for the first parallel side. According to the Snell's law, sin I1 by sin R1 can be written as N21. Right? N21. Why? Because if I just take this one as N1 and if I just take this one as N2. And again I am going to consider this one as N1. So my dear students, the ray of light is traveling from N1 to N2. Similarly, now for the second phase, the ray of light is for at the AD phase. The ray of light is traveling from glass to A. So that here the ray of light is traveling from glass to A. That is from, it is traveling from which one? It is traveling exactly from this medium to this, right? That is what N2 to N1. So that N12 can be written as, right? So hope you know that already in the previous class I shown you how to represent this N12 and N21. As I shown you how to represent in the previous class. So similarly both are inversely proportional to each other. Inversely proportional to each other. So that how to write this N12. So even this N12 can be written as, see I am just writing it here. So N12 can be written as sin of. See my dear students, both are inversely proportional. Both are inversely proportional. That is what N21 and N12. That is I am writing N21 is equal to 1 by N12. So here we have N21, right? So let us write it here. So that is what sin I1 divided by sin R1. Similarly equal to 1 divided by, I want to write the value of N12 now. You can observe the diagram carefully. I1 is the angle of incidence for the first phase, whereas R2 is the angle of refraction for the second phase. Now here according to the Snell's law, it can be written as sin I2 by sin R2. Right my dear students? I am just writing it here. So what is this N12 now? It is written as sin I2 divided by sin R2. It becomes to the numerator. So sin R2. Right? Observe this diagram carefully. According to the mathematics, R1, I2 both are same. R1, I2 both are same. So here from figure, R1 is equal to I2. Right. If R1 and I2 both are same, so these two things cancel with each other. Remaining is sin I1 is equal to sin R2. Sin cancel, I1 is equal to R2. Dear students, I1 is the angle of incidence, R2 is the angle of emergence. So that in case of parallel glass slab, I is equal to E. So one thing you should remember that here this emergent ray is parallel to the direction of incident ray. The emergent ray is parallel to the direction of incident ray. So that reason angle of incidence is equal to angle of emergence. And you can observe that if this glass slab is absent, if these parallel sides are absent, the light may travel in this direction. But due to the presence of the glass slab, due to the presence of the two different mediums here, due to the presence of parallel side, it has emerged out parallel to the direction of incident ray. So that you can observe that there is a perpendicular distance which was present. So this is called as lateral shift. So what is this lateral shift then? How to define the lateral shift? It means actually the ray of light should travel along the direction of incident ray. Suppose the glass slab was absent. But due to the presence of glass slab, it has shifted away. It has shifted laterally. It has shifted laterally. It has shifted sideways. So that what is a lateral shift? It is a perpendicular distance between emergent ray and the direction of incident ray. I am just writing it. It is a lateral shift. It is a perpendicular distance. It is a perpendicular distance between the direction of incident ray and emergent ray. Yes, this is the definition for lateral shift, and this is the diagram for how the lateral shift takes place, how the sideways shifting takes place due to the refraction in case of parallel sided glass slabs. Now dear students, hope you got this formula. Even we have some formula. We have the formula for lateral shift. So what is the formula for the lateral shift? Let us observe the formula for the lateral shift. Dear students, lateral shift is represented by the letter L suffix S, whereas the formula is T into sine of I minus R divided by cos R. T into sine of I minus R divided by cos R, where T is the thickness of the glass slab, I is the angle of incidence, and R is the angle of refraction. Now let us see. So there is no derivation for this lateral shift. So just remember this equation, which is useful for your competitive examination. Now let us see when the lateral shift is maximum and when the lateral shift is minimum. So let us see that maximum and minimum cases. Yes, my dear students, suppose if the angle of incidence is equal to, see here, I am just considering if the angle of incidence is equal to 90 degree. Right. If the angle of incidence is 90 degree, means exactly it is perpendicular this normal. It means the angle of incidence and the light ray is incidenting along this direction. That is said to be the angle of incidence is 90 degree. Then what happens to this formula? Ls is equal to T is the thickness of a glass slab, sine of 90 minus R divided by cos R. Hope you got sine of 90 minus theta. It is a first quadrant. So that sine it is of course everything all are positive in the first quadrant. So that it is plus. And now sine of 90 minus theta, 90 is there. So that it changes sine to cos. So that 90 minus theta, 90 minus sine of 90 minus R becomes cos R. So cos R cancel with each other, remaining is T. So that Ls is equal to the lateral shift is equal to the thickness of a glass slab. So you can observe that lateral shift is this perpendicular distance. Now this perpendicular distance is exactly equal to that of the thickness. If that much you can observe, it means the emergent ray is exactly going to cover the thickness of a glass slab. Right. Now minimum case. For this minimum case, the angle of incidence is equal to 0 degree. What is this 0 degree indicates? It means the ray of light is incidenting along the normal. It means normal incidence. Angle of incidence is 0. It means it is a normal incidence. I already said you that for normal incidence, angle of incidence is also equal to 0. and angle of refraction is also equal to 0. What happens to this formula now? LS is equal to, see, 0, sin 0, right? Becomes 0, 0 by anything is 0, 0 into anything becomes again a 0, so the lateral shift is 0. So for normal incidence, lateral shift is minimum, and for which one, 90-degree incidence, so that the lateral shift is maximum. Hope you got. This is one of the first consequence that we can observe in case of refraction. Hope you all written the diagram. Yes. Now let us move towards the second thing. That is what normal shift. So my second consequence is normal shift. I'm moving towards the second consequence. That is normal shift, dear students. So I'm just discussing this normal shift now. So discuss the normal shift. So I already said you. Suppose if I place a glass slab on the book, so the letters appears to be raised. Suppose if I just place, if I just observe a coil which is under the beaker containing the water, so it is also observed to be shifted upwards. Otherwise, yesterday in the yesterday class, I just given you the example that a bird which is flying in the sky is going to observe the fish which is inside the sea. So that for the bird, the fish appears to be very near as compared to that of the vertical distance. Why? Because the distance it has been raised. And it is obviously, we cannot exactly measure the depth of the sea just by observing through the water. Why? Because it is again due to the refraction. These are all the consequences that we are observing. So now let us first write down the diagram and also let us define what is normal shift and how actually this normal shift is going to take place. For this reason, I am just going to write two different medium here. I am just going to write two different medium, right? So as my dear students, here I am just considering this one as a denser medium, whereas this one as a rarer medium, right? Now, here I am going to place an object or I am going to place a coin. So the object is here, right? Let us write a normal. Yes, let us write the normal as n and represent the normal as n. Now, actually, the rays of light from this object is coming in all the directions. The rays of light from the object is coming in all the directions. Sorry. So I'm not exactly to write this right now. Okay. So then I'm writing this. Okay. Here the ray of light is coming from the object. My dear students, at this position, again I am going to draw the normal, right? At the point of incidence n dash, and at this point of incidence even write the normal n double dash, right? Now, here the ray of light is traveling from denser medium to rarer medium. So the ray of light should bend away from the normal. It should bend away from the normal. Similarly, this ray is also going to bend away from the normal, dear students. Now, if I just extend this refracted ray, these two are the refracted rays. If I just extend these two refracted rays, you can observe that I am just extending these two refracted rays so that they are going to meet exactly at a single position. I am going to write this as O dash. Right, let us give the name. OP is an incident ray, OQ is an incident ray, PR is a refracted ray, and QS is a refracted ray. See, the object is exactly in a denser medium. Assume that this is a water, inside the water the object was present. So that the light ray is coming from the object. So due to the refraction, the ray of light is traveling from denser to rarer medium. It bend away from the normal. So here, this is said to be the angle of incidence and this is said to be the angle of refraction. This is said to be the angle of refraction. Similarly here, the angle of incidence and the angle of refraction. We can observe it. Alright. Let's go. Then see my dear students, this is the original depth of the sea. So I am just writing this one as real depth. This is said to be the real depth, right? And even you can observe here, so that even you can observe here, this is the position of image, this is the position of image, this is the position of object, right. Now here the distance between this position and this, and here there is a position between the image and the refracting surface. So this is said to be the apparent depth, and this is said to be the normal shift. So let us define it once again. So my dear students, so just I place an object inside a denser medium so that the rays of light are coming in all the directions, so that after refraction, so that it went away from the normal. So if I just extend these two refracted rays, it has been joined at this point, so that now assume that the fish is inside the water and the person is observing from this position. The person is observing from this position, right? Now for the person, the object appears to be in this position, not exactly in this position. The person who is observing the object, this object appears in this position, not at this position. It means this is not the original position of the object, but this is the original position of the object, right? So that this is the position of an image, so that the object has been, the image of an object has shifted normally, shifted perpendicularly, shifted normally. So that shift is called as normal shift. And my dear students, you can observe that exactly the depth, that is what the distance between the object and the refracting surface. This is said to be the refracting surface. This is said to be the refracting surface. So I am just saying, I am just defining the distance between the object and the refracting surface is real depth, because it is the original depth. Whereas the distance between the object and the refracting surface is apparent depth. It means it is not a original depth. It is not the real position of the object, but it appears at that position due to the refraction of light. That is said to be the apparent depth. So my dear students, I am just representing it out here. So let us define what is a normal shift, what is apparent depth, and what is real depth. So just want to write the real depth now. So what is the real depth, my dear students? Real depth is the distance between, it is the distance between object and the refracting surface, and the refracting surface. That is called the real depth. Even it is represented by capital or capital D. And another thing is apparent depth is written as AB. Apparent depth. Right. What is this apparent depth? It is a distance present between which one? Image of which one? Image of object and refracting surface. And refracting surface. That is said to be the apparent depth. We define apparent depth and real depth, right? This is our real depth and this is said to be the apparent depth. And the next thing is, let us define the normal shift. What is the normal shift? The shift in the position of an object when the ray of light travels from denser medium to rarer medium. That is said to be the normal shift. Otherwise, we can say that the distance between the object and the image along the normal, or when it is viewed normally, when the ray of light travels from denser medium to rarer medium. That is said to be the normal shift. So this is about the normal shift, apparent depth and real depth. My dear students, even we can write the formula for the refractive index. Why? Because this is a rarer medium, or you can consider this one as a medium with the refractive index n is equal to 1. And suppose if I consider this denser medium as a water medium with the refractive index which is equal to n, then how to write the refractive index? Refractive index is written as the real depth ratio of the real depth divided by apparent depth. So this formula that we can use for the calculation of the refractive index, and as well as even you can use it for the calculation of real depth and apparent depth. This is about normal shift, my dear students. So, and for your competitive examination purpose, even you can write the formula for normal shift also. I am just writing out the formula that is only for your competitive examination purpose. Normal shift is represented as N suffix S. It is written as T into 1 minus 1 by N, where T is the thickness of the denser medium and N is the refractive index of that particular medium. This is about the normal shift. Okay, yes. Now we just completed the normal shift and the lateral shift. And now let us discuss the next consequence, that is delayed sunset. Delayed sunset and early sunrise. So this is what the natural phenomena that we observe every day, right? That we observe every day. So my dear students, so you know that Earth is there, whereas Earth is surrounded by the atmosphere. Earth is exactly surrounded by the atmosphere. So if the Earth is surrounded by the atmosphere, then we can say that it is made up of n number of layers. See, I am just going to write the Earth here. So if I just consider this as the Earth, right? Around the Earth there is a presence of atmosphere layers. So whereas this is said to be the atmosphere layers. So these layers are all exactly parallel to the Earth's surface. Please be careful. The atmosphere layers are exactly parallel to the Earth's surface. Now, each layer of this atmosphere is having its different refractive index. Dear students, as we move high, the refractive index decreases. As we move high, the refractive index of the layers decreases. That is what optical density decreases. So it means, I am just saying, the ray of light, when it comes from the sun, it is coming from rarer medium to denser medium. See, this is the Earth. If I am just moving above this Earth, here the refractive index is more, here the refractive index is less. It means the optical density is more near the Earth's surface and optical density is less at the outer atmospheric layer of the Earth. One thing, my dear students, it means this becomes a rarer and this becomes a denser part. For my explanation, see here I am just going to consider an horizon. So you can just show the horizon. So always when we are discussing it, so that I am just going to write an horizon here. So horizon I am writing. So this early sunrise and early sunset I am discussing, right? So that I am just going to place the sun here. Right. Sun is here. Now, the rays of light from sun. See, my dear students, the rays of light from sun is going to incident at the atmospheric layer. So we have so many layers. So the layers are having a refractive index which is varying from one layer to another layer. Whereas at this position the refractive index is less. When we reach towards us, the refractive index is high. So that the ray of light is traveling from rarer medium to denser medium. When a ray of light travels from rarer to denser, it appears to bend, right? It appears to bend towards the normal. So as if it is moving from denser to rarer, it appears to bend, my dear students. So now I am just showing it for you, my dear students. So let us observe that the ray of light is going to travel from sun towards the earth. So that after refraction it bend towards the normal. And here the observer is present. So that if I just extend this refracted ray, so the sun is, if I just extend this, the sun is exactly normal. This is the apparent position. See, always the sun is below the horizon during morning time. So due to the refraction by the atmospheric layer, what happened? The sun is exactly below the horizon, but due to the refraction, we observe the sun is above the horizon. It means we observe the sunrise 2 minutes earlier. Similarly, we observe the sunset 2 minutes delay. So due to this reason, the complete daytime has been extended by 4 minutes. So early sunrise and early sunset is also due to the refraction, and also it is due to the change in. It is also due to the change in the refractive index of the layers of atmosphere which is present in the Earth's surface. Yes. Okay. Now let us move towards one of the next best phenomena, that is what? Total internal reflection. I am just moving towards total internal reflection. There is lot to study in total internal reflection, my dear students. So, yes, what is this total internal reflection? Ma'am, we are discussing regarding the refraction. Then why you are moving towards the total internal reflection? So simply that the total internal reflection can be written as TIR. So my dear students, so when a ray of light travels from denser medium to rarer medium. See, when a ray of light travels from denser medium to rarer medium, so we can observe that the total internal reflection is possible. It means the amount of light ray which has been incident should completely reflect back to the same medium without undergoing any single part of refraction. That is said to be the total internal reflection. Not only that, let us observe it with the help of a diagram. I am just writing a denser medium. So I am just going to name this one as denser medium. Right, I am just going to name this one as denser medium. Right, so now this is said to be the object O. Right, whereas this is said to be the rarer medium. Right, now this is the normal. If a ray of light is going to travel along this normal, it doesn't undergo refraction, it traces on the same path. Now, if the object was present here, it is going to send rays in all the directions, right? Now, I am going to incident a ray of light at a diffracting surface. See, this is the surface which is going to refract the incident beam of light, because this is the surface which is going to separate its rarer and denser medium. So at this point of incidence, that is said to be the angle of incidence and this is said to be the normal. So the ray of light is travelling from denser medium to rarer medium, so that the ray of light bends away from the normal. It bends away from the normal. Similarly, if I just because here we are not observing the total internal reflection, still I am just going to increase the angle of incidence. So I am just going to increase the angle of incidence. So here at this position again I am going to draw the normal. So at this position again we observe that still more refraction is possible. So whereas this is said to be the angle of refraction, this is the angle of incidence and this is the angle of refraction. Even if I increase the angle of incidence, whereas that angle of incidence is called as the critical angle, so that the angle of incidence is called as the critical angle, called as represented as ICC. For normal incidence there is no refraction, there is no reflection, but if I increase the angle of incidence, some part of light is refracted. Even if I just increase the incidence, we are observing the refraction. But for a particular angle of incidence, the ray of light is just going to graze the refracting surface. It is just going to graze the refracting surface. That is what the angle of refraction becomes equal to 90 degree. Right? So this is the denser medium with refractive index 10. This is the rarer medium with refractive index 1. Dear students, see, for a particular angle of incidence, say critical angle of incidence, the light ray just grazes the refracting surface so that the angle of refraction becomes equal to 90 degree. Dear students, even if you increase the angle of incidence, greater than the critical angle, even if you increase the angle of incidence greater than the critical angle, what happens? The ray of light completely reflects back to the same denser medium, right? So you got this. So this is the diagram for the total internal reflection. So what I just made, if a ray of light is going to allow to pass through the normal, so that the angle of incidence and the angle of reflection and angle of refraction both are equal to 0. If I increase the angle of incidence, then we can observe the refraction. Still more, if you increase the angle of incidence, we can observe that the refraction is going to increase. If you just again increase the angle of incidence, so that for a particular angle of incidence, the angle of refraction becomes 90 and the refracted ray just grazes the surface, refracting surface. That angle of incidence is called as critical angle. And even if you increase the angle of incidence greater than the critical angle, the ray of light is completely reflected back to the same medium. So that's my dear students, what are the conditions for total internal reflection? Conditions for total internal reflection. So that the conditions for the total internal reflection is the ray of light should always travel from denser medium to rarer medium, and the angle of incidence should always be greater than the critical angle, so that we can observe the total internal reflection. These two are the main important conditions required for total internal reflection. So that the conditions we observe, then what is the total internal reflection? See that, let us define this. When a ray of light incident with an angle greater than critical angle of incidence from denser to rarer medium, it undergoes total internal reflection. This is the phenomena when a ray of light, travels from denser to rarer, and the angle of incidence greater than the critical angle, we can observe the total internal reflection. This is about a simple definition for total internal reflection, and also the conditions and definition and diagram. Now let us see what is critical angle. Right. So critical angle represented by IC. See, it is the particular angle of incidence. It is a particular angle of incidence for which the refracted ray grazes the refracting surface. For R in bracket, angle of refraction is equal to 90 degree. This is the definition for critical angle, because you might have observed here. So if for a particular angle of incidence, the light ray has been just grazed, that angle is called as critical angle, represented by IC. My dear students, when the angle of incidence is critical angle of incidence, then the angle of refraction becomes equal to 90 degree, right? So by just using this, let us move for the calculation of refractiveness. relation between refractive index and critical angle. Right. Now let us see here. We know that from Snell's law, sin I by sin R can be written as N. That is what? Refractive index, right? My dear students, here in this case, I is equal to IC and R is equal to 90 degree, right? So I am just substituting here. So it becomes sin IC divided by sin 90, which is equal to N. Now the ray of light is traveling from denser medium to rarer medium. So it means I can write it as, see here we have two mediums, right? One is with refractive index 1 and another one is with refractive index N. So my dear students, sin 90 is equal to 0. So sin 90 is 1. Sin 90 is 1. So here I should not write it as simply N. Why? Because here we have the two different mediums. Suppose we have the air medium, easily we can write it as 1. Suppose we have, so that simply I write it as N. Why? Because here we have the denser medium. But suppose if I just consider that this is a medium with refractive index N1 and this is a medium with refractive index N2. So that here I should replace that the refractive index of the rarer medium divided by refractive index of denser medium. Similarly, here the same thing will come. Refractive index of the rarer medium is 1 and refractive index of the denser medium is N. Suppose if the rarer medium is equal to 1, then denser medium is equal to N. I am showing you two different cases so that this becomes equal to 1 by N. Now finally that sin IC is equal to 1 by N, where IC is the critical angle, N is the refractive index, so that the relation between N and IC is sin IC is equal to 1 by N. So I just shown you. So if I just substitute N directly, that is what absolute refractive index, will get a wrong answer. So that, my dear students, we just exactly use for the pair of medium. That is what the refractive index for pair of medium. That is what refractive index of rarer by refractive index of denser medium. So this is what the relation. So don't forget to write the notes. So try to complete the notes and maintain separate notes for the topics that what I am going to teach you, dear students. Just I am going to correct you when you come to the school. Thank you, dear students.